Regression analysis is to estimate a function which is used to describe the relationship between a dependent variable and some independent variables. The function f describes systematic variation, while epsilon describes the unsystematic variation or random error. The random error is usually due to uncertainty and some missing predictors which are not in the model. In a regression model, we have variables, and variables include independent variables and dependent variables. Independent variables are also called predictors, which are the inputs to the model to predict an outcome. For example, H1, H2, etc. A dependent variable, or sometimes we also call target variable, is the outcome you want to predict with the inputs. The dependent variable or target variable is usually denoted as y. In a simple linear regression model, we assume we have a predictor and a target variable. The intercept of the model is beta naught, and the coefficient of the variable x1 is beta 1. The goal of regression analysis is to find accurate estimates of beta naught and beta 1, which are b naught and b1. Now consider the relationship between the predictor variable advertising and the sales, which is the target variable for a company. As advertising increases, sales should increase as well. But how would we measure and quantify this relationship? In R, you use the LM function for fitting a linear model. Basically, you give it a formula in the first argument and the data in the second argument. There are three ways of fitting a model. In option 1, given a data frame which has the data, we refer to the columns for y and to the column for x, and then call the LM function, give it the formula with the relationship between the target variable and the predictor variable. In option 2, the column names or variable names are used directly without the name of the dataset of the data frame. And the name of the data frame is then given in the second argument to the function. In the last option, we attach the data frame so that later on we can refer to the columns directly. The summary of the regression reveals insights and provides information. Once a model has been trained, you can use the summary function to collect some insights from the model. We will look at the details of the printout later. For now, just look at the estimates for the intercept and for advertising. Those estimates form the linear relationship between y and x. Y is the sales and x is advertising in $1,000. The function fitted provides you with the predicted values. In the first example, given a trained model, Reg 1, you refer to the coefficients. Coefficients 1 is the intercept, and coefficient 2 is the coefficient of x. This way, you manually calculate the predicted values of the target variable. In the second command, you can use the fitted command, the fitted function, and give it the model that was trained or fitted before. There are some assumptions. The error are normally distributed with the mean 0 and standard deviation sigma. We can actually evaluate this based on the residuals. A residual is the difference between an actual dependent variable value and its predicted linear value. In R, we can simply use the residuals function and give it the model. In this case, Reg 1. Then we can conduct a sub-row test. Another assumption is homoscedasticity, which means the standard deviation sigma is constant. And the independence of errors from predictions, independent variable, and time. We can use the BP test function for this purpose. This function is in the LM test package. The last assumption is that the errors are independent from each other. It is noted that the regression equation shouldn't be used to predict values outside the range of predictor variables in the data. How do we measure variations? The total variation is made up of two parts: regression sum of squares and error sum of squares. Y bar is the mean value of the target variable. Yi is the observed value of the target variable. And Yi hat is the predicted value of the target variable for a given xi value. The total sum of square, which is abbreviated as SST, is the total variation. It measures the variation of the observed values of the target variable around the mean. Next, at SR, or regression sum of squares, is the explained variation attributable to the relationship between x and y. And finally, at SE, or error sum of squares. At SE is the unexplained variation, which is the variation in y attributable to factors other than x. In this illustration, for one point xi, yi, we can see how at ST, at SE, and SSR are calculated for 1 point, and then sum over for all the points. We can easily calculate at SE, at SR, and at ST. If you are asked which option do you think show a better fit of the linear model, and which one you select, Looking at RSE, you can see and you can select the one with lower error.